This lesson will focus on trigonometric ratios of acute angles. All the triangles here will only have angles 90 degrees or less, and we'll show how to use those trig ratios to solve triangles. And in the top of the page here are listed the 6 trig ratios. In grade 10 you probably talked about sine, cos, and tan. There actually are 3 others as well. In any right triangle you label the sides in reference to some angle, and that angle is usually one of the 2 acute angles, either here or up here. Now in this triangle, the hypotenuse is always the side opposite the right angle, but the other 2 sides are always in reference to this angle here. And the side that's beside that angle, that's not the hypotenuse, is called the adjacent side, because adjacent means beside. The side that's straight out from or opposite from the angle is called the opposite side, and that's my abbreviation for opposite. So after labeling the 3 sides, the sine ratio is the ratio of the opposite side to the hypotenuse. So it's the opposite side divided by the length of the hypotenuse. That's the sine of this ratio. The cosine ratio is defined to be the adjacent side divided by the hypotenuse. So we would take the length of this side and divide it by the length of the hypotenuse for the cosine ratio. The tan ratio is the ratio of the opposite side to the adjacent. Now, those are the 3, they're called the primary trig ratios. There's 3 other trig ratios that aren't used a lot in mathematics anymore, but you will see them somewhat, especially if you go on to more advanced mathematics, especially beyond high school. And CSC stands for the cosecant. And cosecant is just the reciprocal of sine. Sine is opposite of hypotenuse. Cosecant is hypotenuse over opposite. The cosine ratio was adjacent over hypotenuse. The secant ratio is its reciprocal, hypotenuse over adjacent. The reciprocal of tan, tan being opposite over adjacent, is cotan. The cotangent is the adjacent side divided by the opposite. Now the reason that these were created a long time ago is before people had scientific calculators or computers. These ratios made it easier to solve problems, because in some of the applications you might use sine, cos, and tan, you had to divide by decimals, and in these ones you'd end up multiplying, and it's easier to multiply by decimal than it is to divide. That's the reason they were created a long time ago. I will show some of them in some of the solutions on this page and the next. Now in this example on the first page, Eva sees a 4.5 meter tall tree. So here's a 4.5 meter tall tree, and we're told that the angle of elevation from her, and we'll talk about from her foot right at the bottom of on the ground, is 12 degrees, and we're asked how far away is the tree. So we need to draw a triangle, and so here's our triangle, and we're told that the tree is 4.5 meters tall. So this side's 4.5. We would have a right angle right here. We're asked to find how far she is away from the tree, so we're asked to find this side in the triangle. Now the angle of elevation means from her up to the top of the tree. That angle right there is 12 degrees. That's what angle of elevation means. If you were a bird sitting on the top of the tree looking at Eva, then the angle with the horizontal right here would be also 12 degrees. That would be called the angle of depression down to Eva. Now in this triangle we should label the sides, which are the opposite hypotenuse adjacent. And so for the 12 degree angle, the tree is the opposite side. That's the 4.5 meters. The D, which we want to find, is called the adjacent side because it's beside the 12 degree angle. This would be the hypotenuse here. We don't really need the hypotenuse, so we don't need to label the diagram. Now, the 2 sides we're working with, the opposite that we know, and the D, the adjacent side that we want to find, those 2 sides, opposite over adjacent, that's the tan ratio. That's why I could use the tan ratio. I couldn't use the sine ratio from the beginning here, because sine is opposite over hypotenuse, and that doesn't involve the adjacent side. I want to find the adjacent side, so I need a trig ratio that involves adjacent. Now, I wouldn't be using the cosine ratio even though it involves adjacent, because cosine is adjacent over hypotenuse. We'll be working with this side and this side here, and we don't know either of those, so that's why I wouldn't use cosine. So I would use tan because it involves the side we know and the side we want to know. So that's why I would use tan. Now the next thing I would do is fill in the knowns. The angle is 12 degrees. The opposite side is 4.5, so in place of opposite side we put 4.5. And in place of the adjacent side I put the d. The d is what we want to find. That's the distance. Now remember the tan here, tan of 12 degrees, if you don't see a denominator, it's automatically 1. So cross multiplying here, the d times the tan of 12 degrees would equal 4.5 times the denominator 1 here, or just 4.5. Now I want to solve for d. The d is multiplied by this tan, and so I would divide both sides by the tan of 12 degrees. So the d works out to be 4.5 divided by the tan of 12 degrees. And just to show you how I would punch that in my calculator, I would type in 4.5, and actually you have to make sure your calculator is in degree mode. If you press mode here, notice my calculator is in degree mode. So 4.5 divided by the tan of 12 degrees. And so that's where my 21.2 to 1 decimal place comes from. So D is 21.2 meters. That's how far Eva is from the tree. Now I don't want to just show you one solution here. I want to show you more than one solution. And so an alternate solution to finding the distance is, because we use the tan ratio, because we had the opposite and adjacent side, we could actually use the cotan ratio, because it involves the same two sides, just in a reciprocal order. So cotan is adjacent over opposite. So filling in the angle 12 in place of theta, the adjacent side's the d, and the opposite's the 4.5. Now, in order to find d here, I would cross multiply, and d times the 1 down here is just d. It would equal 4.5 times the cotan of 12 degrees. So all we have to do is find the cotan of 12 and multiply it by 4.5, as opposed to taking 4.5 and dividing by the tan of 12. You see, before people had scientific calculators, this is a more difficult calculation, because you're actually dividing by a decimal. The tan of 12 degrees is a decimal. It's easier to multiply a number by a decimal than it is to divide by a decimal. So in my calculator, this is what I would do to find. Now notice here it says cotan of 12 degrees is 4.7046. A couple ways you can get that. If you take a look at a trig table that involves all the trig ratios of sine, cos, tan, cotan, secant, and cosecant. So notice the angle is on the left side here, and then it goes, each column is one of the trig ratios. Now we want the cotan, okay? So I want the cotan of 12 degrees. So here's 12 degrees. So I will come across here, and there's the 4.7046. So that's the cotan of 12 degrees is 4.7046. Now you could also get that from your calculator, because cotan and tan are reciprocals. So if you don't have this piece of paper with you, you could actually go 1 divided by the tan of 12 degrees. And that's another way you could get 4.7046. You could also actually type in your calculator tan of 12 and take its reciprocal. Remember, the power of -1 means the reciprocal. That's another way to get 4.7046. So actually you've got several ways to evaluate any of the reciprocal trig ratios. Notice on a scientific calculator it only has sine, cos, and tan. You have to do the reciprocal thing to find a cotan value or a secant value or a cosecant value. So back to the PowerPoint. So I'm multiplying 4.5 by that 4.7046, and again that gives us 21.2 meters. So I just want to show you two different solutions that you could use to find Eva's distance to the tree. And of course we answer the question. She's 21.2 meters from the tree. In any of these problems, if you only know two sides, that restricts you to only one of a couple trig ratios. I talked about why you couldn't use cosine, because it involves the side you want to find and another unknown side, so that's why I wouldn't use cosine or secant. Flipping over